Okay, so let's go to number 8, starting this question that is on probabilities. Okay, so let's assume that October 31st, I'm sorry, the 13th, 2019 is a Sunday. By the way, it was, you can look it up. What is the probability that the 15th, which is 2 days later, is a Sunday? Okay, so what's the probability that you have Sunday and then 2 days later you have another Sunday? Okay, the answer is 0, right? So this is all, basically all you're asked to know here is that the probability of an impossible event is 0. How about the probability that 2 days later you'll have a Tuesday, 2 days after Sunday, a Tuesday? The answer is 1. And again, all you have to know here is that the probability of a certain event, I mean the certain event, I don't mean like a certain thing happens. Certain means certainty. A probability of something that is certain to happen is equal to 1. All right. And any probability of any event is going to be between 0 and 1. Okay, so that's all you have to know here. Number 9, the coin is tossed 6 times. How many outcomes are there? Right, so tails, heads, tails, tails, heads would be one of them, right? So how many? Well, there are 2 possibilities for the first, heads or tails. And then regardless of what the first outcome is or what the first result is, you can have for the second one, heads or tails. And so if you only had it 2 tosses, or if you had a coin that's tossed only twice, you have 1, 2, 3, 4. How are we getting this? Well, you have 2 for the first, 2 for the second, 2 for the third, and so on. And because these are all independent, meaning that the earlier coin toss does not influence in any way the current coin toss. So this is 2 to the 6, 2 multiplied 6 times together, and that is 64. You have 64 outcomes here, and if you need to, you can list all of them with T's and H's, and you can verify that you have 64 outcomes. Number 10, these are not too bad, hopefully. Oh, by the way, this is an example of what we call the multiplication rule. Okay, because you're just multiplying the number of the results for each coin toss. Okay, number 10, 2 coins are tossed. Okay, so again, remember you have H, and then HT. I'm just actually reading off of this tree diagram. TH and TT. This, by the way, is called the an alphabetical order or lexicographical order. And it is kind of important to keep track of your order. It's the best way to sort of keep track of, which ones are listed and which ones aren't. Because if you try to randomly list these, you may have duplicates or you may miss a outcome. All right, what is the probability that you have at least 1 heads? Okay, so you can just list all of these and count. What is the probability of having at least 1 heads? Okay, well, here you have 2, here you have 1, here you have 1, right? So this is actually 3 out of 4. And the way you know this in this particular approach is to actually count. Okay, now you could also do this in using what we call the complementary probability, right? So that is to think of the opposite. What is the opposite, or the negation of having at least 1 heads? Okay, if this is your event E, the negation, which we can indicate this way, is the probability of not having at least 1 heads. In what possible ways can you have this false? In other words, in what ways can you have not at least 1 heads? Okay, if you have 1 head, that's okay. If you have 2 heads, that's okay. So the only way this will not happen is the outcome of having no heads, right? And so that would be equal to 2 tails. Okay, that's the only way to have or to not to have at least 1 heads. And that is, of course, 1 out of 4. And so if you subtract 1/4 out of 1 from 1, you get the correct answer as well. All right. Okay, number 11. If you have 6 photos to be included, all right, so remember you have 6 photos to be included in an album. How many ways can you do that? How many ways can you arrange them? All right, 2 things to keep in mind here. Number one, you're arranging objects, okay? 6 different photos. So you cannot repeat the same photo in 2 or more different places, okay? So in other words, no repetition allowed. Did you get that from this problem, from reading this problem? No repetition allowed. This is important because remember, up here, you are, of course, allowed to have repetitions, right? You can use H twice, not here, because when you talk about physical objects, more likely you will not be allowed to have repetitions. So no repetitions allowed. And is the order important? Yeah, because you are including them in an album, and the key word here is to arrange. Okay, you're not just picking like 3 out of 6. You are arranging them in a specific order, so the order is absolutely relevant. Okay, and if the order is relevant and no repetitions allowed, we have what we call permutations, a permutations problem. And so the way you think about this is actually you can use that the multiplication principle approach. You have 6 ways to choose the first one, and for each of the ways of picking the first, once you pick the first one, you only have 5 to choose from, right? And once you choose the first 2, you have 4 to choose from for the third, and 3 to choose from for the fourth photo, and then only 2 to choose from for your fifth one. And once you pick all the first 5 photos, there's only 1 left. So you have really no choice but 1 for the last one. So it turns out the answer is 6 times 5 times 4 times 3 times 2 times 1. And this, another way of writing this is 6 factorial. And the reason we use this exclamation mark is because these numbers grow super fast. And so this 6 factorial, if you multiply them together, you get 720. Okay, so there are 720 outcomes here, or 720 permutations, or you can say there are 720 different ways of arranging 6 photos to be placed in an album. Okay, now just to mention, I mean, I told you this is surprisingly big. Just for 6, you have 720. You should try with 10. If you have 10 photos, how many ways can you arrange them? Or if you have 10, baseball players, including the designated hitter, how many lineups can you come up with 10 different players? Of course, that's the same problem as 10 photo arrangements problem. The answer is surprisingly, it's like 3.6 million, right? So these numbers really grow quite fast. 3.6 million ways to arrange 10 photos. Yes, that's right. Okay, number 12. 3 books will be winning the book award this year. There are 6 books to choose from. This is the hardest problem in this segment, I believe. How many ways can you choose these 3 winners? Okay, so you have 6 to choose from. Now let's see. Can you pick one book twice? No. These have to be 3 different books. So no repetition, right? Allowed in choosing those 3 books. They have to be 3 distinct, different books. And then the order, well, the order is not important in this case, because if you pick books A, B, and C, it's the same thing as choosing B, C, and A. These should be considered the same, right? And that's the difference between permutations problems here and the combinations problems here. The numbers will be a lot less, okay? And here's a way to think about this relevant. The way to think about this, and by the way, the reason the order is not important is because you're not picking these 3 books for 3 different awards. You're not picking first, second, and third place winners. If you were picking first, second, and third place winners, then the answer would be exactly this. Well, it's going to be 6 times 5 times 4, okay? Because the order would be relevant. Now, the way you think about this is, though, to think first, if the order were relevant, important, then there will be this many ways to choose 3 books in a particular order out of 6, right? Because you have 6 different ways to choose the first, and then 5 for the second, and 4 for the third. All right, the problem is here, by the way, the answer is 120 up here. If it's 120, you are considering ABC and BCA and ACB and BAC and CAB and CBA, all these different and 6 different ways of picking ABC as different permutations. Well, we can't, all right, because the order is not relevant. All of these 6 selections or 6 permutations should be considered as one combination, right? So you have to divide this number by 6. Now, where did we come up with 6 here? Well, that's if you picked 3 already, how many ways can you rearrange them? Well, 3 for the first, 2 for the second, and 1 for the third, right? So you will have to divide this numerator 6 times 5 times 4 by the denominator 3 times 2 times 1. This is the number of ways you are duplicating the same combination. That's the way to think about this. And this is 3 times 2 times 1, 3 factorial, because you have chosen 3 books, or you will have chosen 3 books, right? How many ways can you write the 3 books in different order? And the answer is 3 times 2 times 1. So in general, for any combinations problem, what you do is you pick the biggest number here. This is the total number of objects. In this case, you have 6 books, and then keep multiplying as you go down by 1. Okay, and the number of numbers you multiply is exactly this number, the number of things you're choosing. Okay, and then the denominator will be this number factorial. So again, trying to rearrange the number of things you will have picked. And so that's the answer here. This will be, well, okay, so this is 120 divided by 6. If this is too much, you can just go ahead and before you multiply, you can just cancel, because 3 times 2 is 6, right? Clearly, you can see the answer is 5 times 4, which is 20. All right, so there are 20 different combinations or 20 different ways to choose 3 books out of 6. If I were to ask you, in how many ways can you pick 3 children to take to the store out of 6 children at home? The answer would be the same. Okay, let's do one more, and then we will go to the next segment of the video. Number 13, you pick 1 card randomly from a standard deck of cards that has 52 cards. What is the probability that the card is an ace? How many aces are there? Well, 1 for each suit, right? And so you have 4 out of 52. The answer is 1 out of 13, or 1/13. Okay, so this was a pretty easy problem. All right, so in the next segment, we will start with number 14.